Dear friends, in this video we shall see how to implement the file systems. Implementing file system, chapter number 11, which is a continuation of your previous chapter 10 regarding the files concepts. So first and foremost thing, we'll see what is file system structure. What do we mean by file system structure? File system structure is nothing but a logical storage unit. It is nothing but collection of related information. A file structure is nothing but logical storage unit and also collection of related information. File system is organized into different layers. It can be organized into different layers. What are those? We'll see in upcoming slides. Next, with respect to disks, disks may provide bulky storage, secondary storage device on which a file system is maintained, where will be maintaining our files or storing our files. Next, they have two characteristics. They possess two characteristics. One is a disk can be rewritten in place. That is, it is possible to read a block from the disk, modify the block and also write back into the same place. Next, second one is a disk can be accessed directly. That is, any block of information, whatever is contained inside the disk, we can access with respect to something called as rotation. With respect to rotation, that is rotating your disk, we can access the information. What is this disk rotation? We'll be studying in detail in the concept of disk scheduling, which comes in your fifth module. Now we shall see what do we mean by different layers, how system files are organized into different layers. As you can see here, you have devices, IO control, basic file systems, file organization module, logical file system and application programs. So now we know what are application programs, we know devices, we know IO control, we know basic file system. Then what is this file organization module? What do we mean by file organization module? File organization module knows about files and their logical blocks as well as physical blocks. By knowing about files and their logical blocks, the location of the file, that is the file organization module, can translate the logical block. It can translate the logical block addresses to physical block addresses. It is going to translate logical block address into physical block addresses for basic file systems to transfer. In order to transfer these basic file systems, this is going to help by translating the logical block address to physical block address. Next, each file's logical blocks are numbered from 0 through n. So each and every physical blocks are numbered from 0 to n, 0 through n. Next, what is this logical file system? Then what do we mean by logical file system? It is nothing but it manages metadata information. That is, the metadata can include all of the file system structures except the actual data or the contents of the files, except that it manages or it has all the file system structures. It has the data regarding or information regarding all the file system structure except the actual data. Next, a file control block contains information about the file, including its ownership, permissions and location of the file contents. These are also maintained with respect to your each and every file structures via file control blocks inside your logical file systems. Next, we shall see what do we mean by file system implementation. Then what is file system implementation? File system implementation is nothing but we know that on each and every disk the file system may contain information about how to boot an operating system stored, and we also can come to know the total number of blocks, the number location of for free blocks, the directory structures and individual files. So here, what is this with respect to control block, boot control block? What do you mean by boot control block? We are aware that whenever the system is on, booting process takes place. So this boot control block contains information needed by the system to boot the operating system OS, to boot the operating system from that volume, that is from that particular storage. Next, volume control block, it contains volume details. It contains volume details, that is per volume or partition details such as the number of blocks in the partition, the size of the block, a free block count and a free block pointers, and so on and so on. This in your UFS, that is your Unix file semantics, it is called as super block, whereas in your NTFS it is stored as master file table. This volume control block is stored as master file table. Next, what is this directory structure? Organizes the file. That is, we know that in order to organize the file, we use something called as directory. So here also, whenever I want to implement a particular file, I can go for directory structure. A directory structure per file system is used to organize the files. It is used to organize the files. Next, a per file control block, that is FCB. Per file control block, it contains many details about the file. Many details about the file, that is, it has a unique identifier number to allow association with the directory entry. It has a unique identifier number to allow association with directory entry. So this is how with this information I can implement a particular file system. Next, we shall see what is inside our file control block. A typical file control block contains file permissions, file dates, that is create, access, write, file owner details, group, and so on. Next, file size, what is the size of the file? Then file data blocks or pointers to the file data blocks. How many data blocks are there and how many pointers are pointing to that particular data block. All these are the information which are provided inside our file control block. That is nothing but FCB. Now, whenever I want to access a particular file, how do I access? So here, if I see, it tells that in-memory file system structures. What is this in-memory file system structures? The in-memory file system structure information is used for both file system management and performance improvement via caching. The data are loaded at the mount time, updated during file system operations, and discarded at the dismount. Several types of structures may be included. What are those structures? An in-memory mount table contains information about each mounted volume. An in-memory directory structure cache holds the directory information of recently accessed directories. Now, say suppose, what is this recently accessed directories, or what is this in-memory file structure system? So say suppose I want to open a file. Whenever I want to open a file, I go to the user space, type the file name or search the particular file whichever I want to open. That is your followed by file name. You open the file name, come to your memory. Come inside the memory where exactly it is stored inside your directory structure. You fetch it. If it is not there, then you go to your secondary storage device. You fetch the file from your secondary storage device, that is your directory structure. Then with the help of your file control block. Why? Because inside my file control block I have all the details about a particular file, that is your file permission, file owner, data size, data blocks, all those things. So with the help of this, I'll be fetching the file if I want to open a particular file. Next, say suppose I want to read a file. When I want to read a file, I have two things to remember. One is per process open file table. Another one is system wide open file table. Per process open file table and system wide open file table. Now the system wide open file table, what is it? It is nothing but it contains a copy of the file control block. Whatever copy is here inside, placed inside my secondary storage device of with respect to file control block, this particular content is being placed inside my system wide open file table. A copy, it contains a copy of file control block of each open file as well as other informations Next, what is the role of per process open file table? Then this per process open file table contains a pointer. It contains a pointer to the appropriate entry in the system wide open file table. It is nothing but it has a pointer which is appropriate entry to the system wide open file table as well as other information. So this is how, when I want to read a particular file, I open the file, I read with the help of the index, that is with the help of my system wide open table. I fetch the contents of file control block where exactly it is located, and then I read the particular file. So this is an example for opening a file and reading a file with respect to in-memory file system structure. Next, we shall see the schematic view of virtual file system. What is the schematic view of virtual file system? As we can see here, the data structures, or as we know that the data structures and procedures are used to isolate the basic file systems, the basic system call functionality from the implementation details. Thus, the file system implementation contains three major layers. It contains three major layers, that is as depicted here, that is your file system interface, VFS interface, and your local file systems. Under that you have the secondary storage devices, disk and network area. So what does this do? The second layer is called as virtual file system layer. That is your VFS, virtual file system layer. This layer, it has two important functions. One is it separates the file system generic operations from their implementation by defining a clean VFS interface. Next, several implementations for the VFS interface may coexist on the same machine, allowing transparent access of different types of file systems mounted locally. Next, it also provides a mechanism for uniquely representing a file throughout a network. The VFS is based on a file representation structure called a vnode. What is this vnode? That contains a numerical designator for a network-wide unique file. This network-wide uniqueness is required for supporting of network file systems. And this vnode is being maintained by kernel. The kernel maintains one vnode structure for each active node. So this is what is meant by the schematic view of virtual file system. Next, we shall see how to implement the directory implementation. So whenever I speak with directory implementation, two things we should keep in mind. One is linear list, another one is hash table. Using linear list of file names with pointer to data blocks, it is very simple to program but time consuming. Whereas hash table, linear list with hash data structure, this will decrease the directory search time, but collisions can occur. Situations where two file names hash to the same file location, and the size is also fixed size is used. Next we shall see different allocation methods. What are the different allocation methods? An allocation method refers to how disk blocks are allocated for files. We have three allocation method. One is contiguous allocation, contiguous. Next is linked allocation. Last is indexed allocation. In detail we'll see what are these things. First is contiguous allocation method. So in your contiguous allocation, contiguous means continuous. Contiguous means continuous. Each file occupies a set of contiguous blocks on the disk. Each file occupies a set of contiguous blocks on the disk. Say suppose you observe in this particular diagram, we have file, we have something called as start and length. What is this start? It tells the starting point of that particular file which is stored, and length tells us the number of blocks used for that particular file. So here if I see count is the file name, it tells the starting block is 0 and length is 2. If I come and see in this disk inside my memory, 0, 1, 2 blocks are used for the file named count. For the file name count. So it tells that simple only starting location and the length are required. Length of the blocks are required. Random access is possible. Next, wasteful of space, that is dynamic storage allocation problem. Because whenever I want to store any of the file, I should see to that the memory is always continuous. If the memory is not contiguous or continuous, then I cannot store my file inside the disk. So files cannot grow. Files cannot grow because I am fixing the length in the starting itself. Whenever I am telling that I want to store the file, I should tell the length of that particular file. Dynamically, I cannot increase the size of the file. So this is with respect to 1. Now if I see file F, it tells the start length is 6. If I see here, start length is 6 and length it tells only 2. So 6 and 7, 2 blocks of data are used. Now if I tell mail, starting address it tells starting point is 19. If I come and see here, starting is 19 here. So 19, 20, 21, 22, 23, 24. So totally 6 blocks. 1, 2, 3, 4, 5 and 6. So totally 6 blocks are continuously allocated for my file called mail. So this is how your contiguous allocation happens. So the main thing you should remember is always the blocks must be contiguous and it is always simple. Starting location should be known, then length of that particular block should be known. So disadvantage is your dynamic storage allocation problem, files cannot grow. You cannot increase the size of the file. Next we shall see what is linked allocation. Linked allocation. Linked means linking the blocks. So each file in a linked list of disk blocks may be scattered anywhere on the disk. It can be scattered anywhere on the disk. So this is one of the solution for your contiguous allocation. Why? Because in your contiguous allocation, if you see here, whenever I want to store the file, the memory should be contiguous. Whereas here it tells that the blocks may be scattered anywhere on the disk. This is the advantage of your linked allocation system. It is simple. It needs only starting address, free space management, no waste of space, no random access, mapping can be done. So here if I see here in the picture, if you see here, you have file named Jeep. It tells the starting address or starting point is given as 9, ending it is telling it as 25. When I come and see inside my disk here, I can see here from 9 it has gone to 16, from 16 it has gone to 1, from 1 it has gone to next block and so on. Whenever I tell that this is the end of the file, I store it as -1 here, -1, -1. So this is the advantage of linked allocation, that is the file can be scattered anywhere on the disk. Blocks can be maybe scattered anywhere on the disk. Next, the one more variation, file allocation table. It is a variation of file linked allocation system. What is this FAT or file allocation system? It is simple but efficient method of disk space allocation that is used by MS-DOS and operating system. The directory entry contains the block number of the first block of the file. Here, if I see here, this is the directory entry. It contains the first block, that is the starting block 217. When I go inside 217 and see, this 217 in turn contains the next block address 618, wherein I go and search inside 618. Again inside the 618 I have another file, another block 339. I go here and I check for another entry. That is, the directory entry contains the block number of the first block of the file. The table entry indexed by the block number contains the block number of the next block in the file. This chain continues till it reaches the last block, which has a special end of file value as the table entry. That is, some special value will be given here which tells that or indicates that it is the end of the file. I repeat, you have the directory entry contains file name as well as the starting block. When I go and search inside starting block, it contains the block number wherein I need to search the next data. And when I come here, again it shows the next block number and so on until I find a special value which tells it is the end of the file. So this is one of the variation, file allocation table. It is one of the variation of your linked allocation system. Last one is indexed allocation method. What does this index allocation method tell you? It brings all pointers together into the index block. How is it? We'll see here. So here if I see, I have directory, I have a file by name Jeep. I tell the index block is 19. When I go and search inside 19, I have all these values. That is where exactly I need to go and fetch for data. From 19, I can go to 9th block, 1st block, 16th block, 10th block, 25th block. It tells the index value wherein I need to go and search for my data. So index allocation, it solves the problem by bringing all the pointers together into one location called the index block. So this is how indexed allocation of a disk space looks like. Next and the last topic for this chapter is free space management. What is this free space management? It tells that, or it gives us the free space list where all the disks are free. To keep track of free disks, that is the space, free disk space, the system maintains a free space list using certain techniques. The first one is here bit vector, next is linked list, grouping, counting, space maps. In detail we'll see what are these. First is bit vector. As the name suggests, bit can be either 0 or 1. So here the free space list is implemented as a bitmap or bit vector. Each block is represented by 1 bit. If the block is free, the bit is 1. If the block is free, then the bit is 1. If the block is allocated, that is any of the data of any of the file is been allocated, then the bit is 0. For example, consider here, say suppose the blocks 2, 3, 4, 5, 8 are free and the rest all blocks are allocated. Then how do I write the free space bitmap? It will be starting from 0th block. 0, 1, 2, 3, 4, 5, 6, 7, 8. So it tells that here, if you read the example once again, blocks 2, 3, 4, 5, 8 are free. Free means it is represented as 1. So here if I tell this is my second block, this is your 0th block, it is telling it is allocated. First block is also allocated. This is my second block which is free. Third block, fourth block, fifth block according to this example 2, 3, 4, 5. It is all free. So I have represented it as 1, 1, 1, 1. Next again 6th block is not there. 7th block is not there here. Directly from 5 it is going to 8. So 6th block and 7th block are not there. That means that 6th and 7th are allocated. Allocated means I represent it as 0. Next again it tells 8th block is free. So again 8th block I will represent it with 1 and so on it continues. This is how I'll come to know about the free space list. The major advantage is that it is very simple to write and the efficiency in finding the first free block or n consecutive free block on the disk is easy. It is easy. I can easily find the first free block or n consecutive free blocks on the disk. This is with respect to bit vector technique. Next we shall see linked list technique. As the name suggests here, linked list. This approach is used to link together all the free disk blocks by keeping track of a pointer to the first free block in a special location on the disk and caching it in memory. The first block contains a pointer to the next free disk block and so on. So here if I see, for example, 2, 3, 4, 5, 8, 9, 11, 12, 13, 17, 18, 25, 26, 27 are free and the rest all the blocks are allocated. That is here. If I see here, block 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 19, 25, 26, 27. He tells that all these are free blocks and the remaining whatever you can see in white they all are having certain data. They are allocated blocks. So block 2 would contain a pointer to block 3 which would contain pointer to block 4 and so on, as you can see here. This is the free space list head which is pointing to block number 2. From 2 it is pointing to 3, from 3 it is pointing to 4, 5, 8, 9. Wherever the blocks are free it is going to be pointing. So this is the major advantage of linked list. The first block contains a pointer to the next address block. That is what it tells. The first block contains a pointer to the next free disk block and so on and so on. Next is grouping. What is this grouping? This is again a modification of the free list approach that stores the address of n free blocks in first free block. It stores the address of n free block in the first free block. The first n-1 blocks are actually free and the last block contains the addresses of another n free block and so on. Grouping can be done. Next, counting technique. Counting technique, how does it help to know about free space? Each entry in the free space list consists of a disk address and a count. It consists of a disk address and a count. These entries can be stored in B-tree format rather than linked list. It tells that in counting technique, B-tree format also can be used for efficient lookup and insertion and deletion of the data, that is list, free space list. Next, last one is space maps. It uses something called as Sun's ZFS file systems. It is a mapping technique. It is a space mapping technique. It uses a combination of techniques in its free space management algorithm to control the size of data structures and minimize the IO need to those structures. So these are our 5 types of free space management techniques. I repeat once again. First one is bit vector, second one is linked list, third one is grouping, counting and space maps. With this, your 4th module is completed. If you have any doubts, you can ask later. Thanks for patient listening.